The relationship between traumatic brain injury and crime, a look at the prison population in North Carolina, by myself, Brittany Sheehy. A traumatic brain injury, also known as a TBI, is damage to the brain resulting from various traumas such as assault. A TBI can negatively impact one's abilities in many ways, such as to make correct decisions, monitor emotional reactions, and to think logically. Commonly, inmates are not screened for TBIs, nor are they receiving the services while incarcerated. Why aren't the inmates screened and provided the services they require? There are many possible causes, such as the judicial system is not aware of the importance, which then causes the prison guards to become unaware that the inmates may become more successful within the prison as well as in society if they receive the services they require. In addition, there's the mere question, if the TBI occurred prior to incarceration, why would the prisons be held reliable for providing services? The further research will indicate that untreated TBIs can influence violent behavior as well as continue to behave violently within the prisons as well as when released on parole if the prisoner is applicable. How can we be sure TBIs influence one to behave violently? Through an unbiased meta-analysis study, Darby and his colleagues researched the topic of brain lesion location within the prison population. Through the use of lesion mapping and functional magnetic resonance imaging, also known as fMRI, they were able to research the following three hypotheses. The location of the prisoner's lesions and violent behavior are connected. Moral decision-making is influenced by the locations of the inmate's lesions. And a prisoner's lesion would reveal different connectivity to opposing regions in the brain. Show me the evidence. The first cohort included 17 inmates. Darby and colleagues investigated the first hypothesis and found the following results. All of the inmates' lesions were negatively connected to the anterior temporal lobes, orbital frontal cortex, and VMPFC. Although the location of the lesions may differ per violent offender, all of the prisoner's lesions present a similar location network at rest. This is referred to as criminality-associated connectivity pattern, also known as brain network. The conclusion was, those with lesions connected to these regions are more likely to participate in harmful acts. As you look in the top right-hand corner of the slide, there are the images of the 17 inmates. Within the 17 inmates, Darby and colleagues were able to investigate the second hypothesis. They found that regions of the brain of the inmates' lesions were negatively connected to the areas that stimulate theory of mind tasks and decision-making that are value-based and moral. In addition, the regions of the brain that were not connected to the inmates' lesions were the areas that stimulate cognitive control and empathy. The conclusion to this hypothesis was, those with lesions connected to these regions are less likely to make decisions that are value-based and moral. As you look in the top right-hand corner of the slide, there are images that indicate connectivity, which are in red, and non-connectivity, which are in blue. Here's an additional visual that shows you the lesion connectivity in red, fMRI activation in green, and the overlap in yellow of the inmates' lesions that indicated value, theory of mind, empathy, and cognitive control. The findings of the third hypothesis are as follows. The inmates' lesions appear to be oppositely connected to the areas that contribute to moral choices. In addition, the inmates' lesions appear to be connected to the areas that stimulate unfair offers and discard self-harm. The conclusions were, prisoners with a TBI are more likely to participate in violent behaviors to achieve utilitarian decisions and discard self-harm as well as unfair offers. When Darby and colleagues replicated this study with 23 different prisoners, they found that within the second cohort, all of the findings within the first cohort were similar. This indicated that both cohorts showed lesions of similar location, moral connectivity, and opposing connectivity. This then improved the validity and reliability of their findings. There are many strengths to this article, such as they use previous lesion location and behavioral testing to prevent task defiance. They also use neosynth to prevent bias when reading neuroimaging. Thirdly, the study was replicated and the findings were similar. The weaknesses of this article were the small sample size within both cohorts, only inmates who were violent offenders who had TBIs were the subjects, results could be biased due to some of the subjects participating in other brain studies, and fourthly, Darby and colleagues were unable to declare whether the TBIs definitely influenced the criminal behavior or if their findings were incidental. In the second article, Ferguson and colleagues were able to investigate the prevalence of TBIs within the prisons of South Carolina. They used the Ohio State University's TBI identification method in order to conduct interviews with inmates within the South Carolina prison population. Who were the subjects? In the dark purple, there were 275 max out, 19 short-term, and 26 long-term male inmates. In the light purple, there are 267 max outs, 15 short-term, and 37 long-term inmates within the female population. Out of the total 636 inmates interviewed, 33% of them did not report having a TBI. However, 67% of them reported having a TBI. That is nearly double the amount of those who do not recall having a TBI. 72% of the female interviewed inmates recall having a TBI. On the other hand, 65% of the male inmates who were interviewed recalled having a TBI. Out of the 431 inmates who reported having a TBI, 35% of them did not recall having a symptom. On the other hand, 65% of them did recall having symptoms. As you can tell by this graph, more males who are serving long-term sentences reported mood and personality changes. On the other hand, more females who are serving short-term sentences reported mood and personality changes. As you can tell by the two graphs, the one on the left is a previous research done, and the one on the right is done by Ferguson and colleagues. They had similar findings between traumatic brain injury prevalence. As you can tell by this slide, previous research done in Ohio found similar average TBI per inmate as Ferguson and colleagues. How do these findings relate? Individuals who have had TBI can face an invisible disability that affects cognitive, emotional, physical, and behavior. If untreated, outbursts, irritability, and aggression will escalate as the individual ages. Prison guards perceive them as defiant, which increases the probability of them having another TBI, thus continuing to damage his or her brain. The strengths of the study include a large sample size, the 9 interviewers were trained and provided a clear, standardized definition of what a TBI is, and the results were compared and found similar to studies in different states. The weaknesses of this article are, some may say a subjective questionnaire is not as accurate as a standardized objective measure, and the results were not compared to those who are non-incarcerated. Ideally, individuals receive rehabilitation services after experiencing a TBI that results in symptoms. However, we postulate that services would be rare among individuals with TBI who later enter the criminal justice system. Therefore, screening and subsequent treatment after initial incarceration would provide an avenue to assist offenders in not returning to prison after release. So in conclusion, it is said society is affected by criminal behavior by approximately $1 trillion, which includes incarcerating individuals over and over again. An inmate who is brain injured without receiving services could potentially be released with a more damaged brain than when initially incarcerated. My capstone will research the following questions. Is there a high prevalence of inmates within the North Carolina prisons who have suffered TBIs? Are the inmates who have suffered a TBI receiving services within the prison population? And how can prison guards and parole officers become more knowledgeable about TBIs in order to help inmates while and after incarceration? My capstone project will include a questionnaire questionnaire to the inmates of North Carolina in the design of member checking to gather information regarding length of sentence, TBI recall, symptoms, change in personality and mood, and whether or not they are receiving services within the prison. In addition, an informational text will be developed to educate prison guards and parole officers on what a TBI is, how to suspect one has had a TBI, and ways in which you can better help inmates who have had a TBI.